In any supermarket, the packaging is a consumer's first point of contact. To be successful, it must keep the item safe, tell you what's inside, and catch your eye against the competition. On a crowded shelf, that box acts as your silent salesman. Every three-dimensional box starts as a flat sheet of paper. If we peel back the glue points of a familiar biscuit box, it unfolds into a two-dimensional layout. This flat blueprint is called a packaging net. To build this structure, you need three distinct parts: the faces that display the brand, the tabs that hold the glue, and the flaps that fold over to close the ends. Designing this requires mathematical precision as much as graphic art. Let's look at the drafting process for a block of shea butter soap. First, we measure the product itself. Here we have a length of 80 millimeters, a width of 50, and a height of 30. However, the final box cannot use these exact measurements. If the box matches the soap exactly, it won't fit. You have to add clearance by increasing every dimension by 1 to 2 millimeters. This creates a tiny pocket of space so the product slides inside without tearing the paper. This extra space is the baseline of structural design. Once we have these adjusted dimensions, we have the wireframe needed to build the rest of the net. Now we translate those 3D measurements back onto a flat 2D plane. We map out the sequence of faces, tabs, and flaps on grid paper to form the full expanded layout. We use specific line types to show how to process the sheet. Solid blue lines along the outer perimeter mean cut here. Dashed red lines on the interior mean fold here. The difficulty lies in visualizing how this flat map behaves in physical space. When you apply graphics to a net, you must know exactly where they will end up once the box is folded. Let's test your spatial awareness. If face A is the front of our soapbox, which letter will become the back panel directly opposite it? Take 5 seconds to mentally fold along the dashed lines. The answer is face C. Orienting your panels correctly during the layout phase prevents your text from printing upside down or appearing on the wrong side of the final product. Once the physical structure is set, we apply the graphics. A shopper takes roughly 3 seconds to make a decision at the shelf. Because of that window, your primary front panel needs a strict visual hierarchy. You must answer 3 questions instantly. First, the product identity. What is the item? Next, the benefit. Why should they buy it? And finally, the proof, a quality certification logo that validates the brand. Your layout must also account for local production realities. Many Ugandan producers use porous cardboard and budget screen printing. Because fine photographic details often blur on these materials, you should use crisp, bold vector shapes instead. By designing specifically for these physical printing constraints, you ensure your brand message reaches the consumer clearly. To know if your hierarchy works, you test it with a mock-up. Build the physical box and place it next to competitors on a crowded shelf. Step back 2 meters. If your box grabs your eye before the others, you have achieved shelf appeal. This process relies on 3 rules. First, build the structure by adding 1 to 2 millimeters of clearance. Second, guide assembly using dashed lines for folds and solid lines for cuts. Third, secure attention with a 3-second visual hierarchy. To continue building your design skills, check out our other lessons on brand identity and explore the full curriculum at Yaka Digital Network. By mastering the mathematical net alongside the graphic label, you take your ideas off the screen and turn them into physical objects that sell.